Hello, sir. My name is Imran Shalabi, and I will be introducing my group's Semantic Web assignment number 5. In a group of 3, myself, Ratul Mazumder, and Mohatma Islam worked together over the course of several weeks to develop an ontology using Protege, based on a domain of our interest. The following is the structured project hierarchy for this assignment, whereby Mohatma Islam was the project leader, and Ratul Mazumder and myself worked together alongside Mohatma as the project development team in order to satisfy the goals and the objectives of this assignment. For this assignment, we were required to develop a complex and relevant ontology satisfying many requirements. For the scope of domain, we chose electronic devices and related it to different hardware devices and software components as well. The class hierarchy describes many classes of electronic devices, such as computers, mobile phones, cameras, and console games. These classes are integrated and linked to different hardware components, such as battery and storage devices, input and output peripheral devices, processor and graphic units, as well as software components such as different operating systems for different platforms and devices. But more on that later when we get into our ontology. The reason we chose this domain was because, as a group, we have sufficient knowledge and a great interest about electronic devices. We also clearly understand a variety of hardware and software components and how they are linked to specific electronic devices. With good knowledge, we dedicated ourselves to developing the ontology in depth, and with our interest in the scope of domain, we were enjoying the development process, which resulted in a good overall performance and collaborations by all group members involved. Moreover, the scope of domain offers an opportunity to explore electronic devices in great detail, which helps us in producing a complex and relevant ontology that satisfies the requirement of this group assignment. The main benefit of developing this ontology is that it provides the ability to define a semantic model of the data combined with the associated domain knowledge, which helps us to define links and infer knowledge and data from the different types of semantic knowledge in relation to the ontology's domain, electronic devices. By developing this ontology, we share the common understanding of the structure of information among the software agents and are able to format and structure data to simplify the understanding and learning process. With semantic web technologies developing rapidly in recent times, it continues to grow, showing the importance of knowledge and technologies working together. By developing this complex ontology based on our electronic devices domain, we can gain a better understanding on facilitating communications among systems without semantic ambiguity, which is an important skill for our future endeavors in the fields of computing and information technology. So moving on to the ontology itself, I have opened our finalized assignment 5 OWL document in the Prodigy software, and in the active ontology tab, we can see our ontology RI, which indicates our scope of domain, electronic devices, and a few annotations regarding our information and information about the ontology as well, with a short description. In the Classes tab under the Entities tab, we can see our complete class hierarchy for this ontology, which consists of several different superclasses and subclasses that indicate the different electronic devices as well as the different components, both hardware such as battery and peripheral devices, for instance, to different software components that are integrated in electronic devices such as the operating systems. And in each superclass, they are further grouped down to different subclasses, which group them based on the type of device. So for instance, in the operating system, we can see that they are grouped by the computer electronic device operating systems to game console, mobile phones, and so on. So in terms of detailed explanations and clarifications regarding the classes, I will focus on 7 different types of classes for this ontology, which are detailed enough to provide clarifications. Starting with action camera and DSLR, both being subclasses of camera under electronic device. Then moving on to laptop and personal computer, subclasses of computer under electronic device. Then moving on to PlayStation, which is a subclass of game console, which is an electronic device. And finally ending with a feature phone and smartphone, both being subclasses of mobile phones under the phone superclass. Now for the camera class, we have defined 3 different subclasses: action camera, digital cine camera, and DSLR. So I will focus on action camera and DSLR alone. Now an action camera refers to the type of electronic device particularly used by bloggers to record action clips and motion clips, hence the name action camera. Now an action camera here is a subclass of camera and it is a defined class. On the right hand side here we can see some equivalencies, whereby the action camera is equivalent to camera and action camera and has camera battery exactly 1 lithium ion. And down here we have defined a few characteristics such as mobility and photography. Now characteristics that we have defined here are to distinguish between members of a class, so that when instances are inferred from that class, it can clearly identify which one belongs to which class. Now if I run the reasoner quickly here, it will infer some knowledge, such as the instance of an action camera GoPro Hero 8, therefore proving that this is an action camera. The DSLR defined subclass over here refers to a digital single-lens reflex camera, which is used for taking really high-quality images. Now DSLR subclass here is also defined through equivalent characteristics, whereby the DSLR is equivalent to camera and DSLR, whereby it has a camera battery of exactly 1 lithium ion, but the key difference to the action camera is that it can possibly also have an exactly 1 camera battery of type nickel metal hydride, which distinguishes it from the action camera. And under here we can see some characteristics which are defined similar to the action camera, such as mobility and photography, so that we can know that these two are cameras. However, they are distinguished through the different types of battery that they contain. So if I run the reasoner here, it will infer some knowledge as well, whereby it's showing that the Sony Alpha 7 A7 is an instance of the DSLR subclass. So now when I run the reasoner here, it shows that the Sony Alpha A7 is an instance inferred from the DSLR class. Moving on from the camera superclass to the computer superclass, it groups a few different types of computer devices such as laptop, mainframe computer, personal computer, server computer, and supercomputer. However, for this discussion, I will focus on laptop and personal computer. Now, a laptop refers to the type of electronic device as a small portable device that performs similar functionality to a personal computer, but it has many integrated devices attached to it. Now, a laptop is also a defined class under the computer superclass, whereby it has some equivalent characteristics. For one, the laptop has a laptop characteristic of some mobility. It also has a built-in component of a minimum 1 speaker, because some laptops have either 1 or more. It has a built-in component of exactly 1 keyboard, since all laptops come with exactly 1 keyboard and 1 touchpad. And it has a laptop battery of exactly 1 lithium ion. Now these equivalencies help define the laptop class and distinguish it from other members of the computer class. Also, the laptop class has been disjointed with the other members of the class over here. Now if I run the reasoner, it will infer some knowledge, whereby it shows that we have 2 instances that belong to the laptop class, the Acer Nitro 5 laptop and the HP Envy X360 laptop, both being subclasses of the computer and belonging to the laptop subclass. In contrast to the laptop, we have a personal computer defined subclass, whereby it is defined through equivalencies here. A personal computer has a characteristic of some stationariness, meaning that it is stationed and not portable like a laptop. It has a peripheral device. Since laptops have built-in components, personal computers have attached peripheral devices through either output or input. So it has a minimum peripheral device of 1 keyboard or 1 mouse or 1 speaker, but that value depends on the user. It has also been disjointed with other computers in the class, and if we run the reasoner here, it will infer some knowledge whereby it shows that the personal computer is obviously a subclass of computer and has an instance of Lenovo V530 Tower, which belongs to that personal computer, and it is defined through the following equivalencies mentioned earlier. Moving on to the game console class over here, we can see that we have defined 3 different types of game consoles. The PlayStation, which is manufactured by Sony, the Wii console manufactured by Nintendo, and the Xbox, which is manufactured by Microsoft. These are particularly the popular ones. Now for this section, I will only discuss PlayStation in depth. Now the PlayStation is a home video game console manufactured by the Sony company. It is a very well-known brand all over the world. Now the PlayStation is defined is a defined class over here under game console. And how is it defined? Through equivalencies here on the right hand side, whereby a PlayStation is equivalent to game console and PlayStation, whereby it has a game console OS of exactly one Orbis OS. And the Orbis OS is the operating system developed by Sony, particularly for the PlayStation device. So if an instance has this Orbis OS running with it through object properties, that instance will be inferred as a PlayStation class. So also here we have identified that a PlayStation has PlayStation feature through an XSD string, which will be identified through data properties. So if we run the reasoner here, it will derive some knowledge whereby it shows that it is a subclass of game console, obviously. And it shows here two instances particularly related to the PlayStation class, PlayStation 4 and PlayStation 5. Now moving on from the game console, we can see here that we have two defined classes under mobile phone, feature phone and smartphone. Now a feature phone refers to earlier generation phones with button-based input and a small display. Now this feature phone subclass has been defined through the following, whereby it is equivalent to a mobile phone, whereby it is running exactly one mobile operating system, and we have put a value restriction here on the price, a data property, indicating that a feature phone cannot be more than 80 ringgit, which defines the class and the instances pertaining to the feature phones. It also shows down here that we have identified a phone characteristic of some mobility. And if we run the reasoner here, it infers knowledge whereby it shows that the feature phone is a subclass of mobile phone, and obviously is disjoint with the smartphone because they're members of the same class. And instances derived show that the Nokia 3310, one of the original phones of our earlier generation times, is derived from the feature phone class as an instance. Now the smartphone class is completely different to the feature phone. With the advancement in technology, it is safe to say that feature phones are well in the past, and the talk of the modern era revolves around smartphones. Now, smartphone as a class here is defined as the type of electronic device running exactly one mobile operating system and has a smartphone characteristic of exactly one touchscreen. Now, the touchscreen identification helps distinguish between feature phones and smartphones so that the instances with the touchscreen can be directly inferred as a smartphone class. Also, we have added a smartphone characteristic of mobility, and if we run the reasoner here to infer some data, we can see that a smartphone is a subclass of the mobile phone, and instances include the Huawei Y9 2019, iPhone X, the Samsung Galaxy S20, and the Xiaomi Note 9.
Hello, my name is Ratul and I'm going to discuss about the object properties, data properties and the instances for our all document. So starting with the data object property, we have has network connection with. So this one basically is to relate a computer to a computer. That means that a computer can have a network connection with another computer. So this object property has characteristics of transitive and symmetry. By transitive, we mean here, let's say if one object is connected, one computer is connected to another computer, and the second computer is connected to a third computer. So we can say that the first computer is also connected to the third computer. And by symmetric here, we mean that if a computer A is connected to computer B, that also means that computer B is connected to computer A. Now moving on to the next object property, we have peripheral device. So has peripheral device, this means that a peripheral device can be connected to an electronic device. So this electronic device, but here we mean a computer. So the peripheral device has few sub properties, which has input device and has output device. So has input device also has the sub property such as has keyboard and has mouse, and the has output device has the property has speaker. And the characteristics of this has peripheral device property is that it's inverse functional. So if we go to the third property connects to, which is the inverse of the has peripheral device, we can say that inverse functional means that one peripheral device can be connected to only one computer at the one time. So let's say if I have a keyboard that is connected to a personal computer, so that keyboard can be used with that computer only that time. Moving to the fourth object property, we have has Windows OS. Has Windows OS is referring to a computer as the domain and ranging to Windows. It's basically meaning that a computer can have operating system which can be of Windows. So this characteristics is functional because one computer can run on one Windows at one time. Moving to the last object property, we have has Snapdragon processor. So this property is under the super property has processor, which has the sub property has mobile phone processor, and this one has the sub properties has Snapdragon processor. So the domain for this object property is smartphone and ranging to Snapdragon processor. So, and it has a characteristic of functional, which means that one smartphone can run on one chipset processor of Snapdragon at one time. Now let us have a look at some of the data properties we have for our all document. So the first one is has storage capacity. So this data property is basically to mean the quantitative value that can be allocated to an electronic device. So this value is the capacity the electronic device can have. So the domain for this data property will be electronic device, and the range will be a value that is of data type double. Next we have laptop display size. So this one has the domain of laptop and the range as double. So this one is basically used to mean the display size of the monitor display size of a laptop. Next we have the release date. The release date is to specify a date on which an electronic device was first released. So the domain will be the electronic device and the range will be the string. Next we have hash price. So this hash price is actually calculated in currency of ringgit, Malaysian ringgit. So the domain will be the electronic device and the range will be the double. So it specifies the monetary value of an electronic device. Last but not least is the hash clock speed. So hash clock speed basically has the domain of processing unit and the range as double. So this clock speed means the processing power of a processor, like calculated in gigahertz, like the frequency at which any processing unit can perform the task. Now moving on to the instances of the classes we have. The first one to discuss is the HP Envy X360. So HP Envy X360 is a lightweight compact convertible laptop developed by HP. So we can see that it is a type of laptop over here, and we all these are the object properties that are associated to this instance. So let's say we has network connection with, and this one is a personal computer, is manufactured by Hewlett Packard, which is HP, has laptop battery of lithium ion B1, has Windows OS, Microsoft Windows 10, has Intel processor of Intel i5 8250U of serial number of this particular serial number, and uses a GeForce graphics card of GTX 1050 Ti. And the data property has weight, which is of 2.13. This 2.13 is a value which is measured in kilograms, and has laptop display size, which is of 14 inches. So furthermore, we can see that after we have turned on the reasoner, we can see that these object properties has been inferenced by the reasoner. So it has computer processor as Intel, and has processor also as Intel. So we basically mean here that uh, has Intel Core processor is a subclass, a subproperty of has computer processor, and has computer processor is also a subproperty of has processor. So similarly for GeForce graphics card, we have the graphics card, and since graphics card is also a type of processor, we can say that it has a super property which is has processor, and also the value GTX 1050 Ti. And since it is running on has Windows OS, Microsoft Windows 10, so it has the super property value of has OS Windows 10, and the then the laptop battery has the super property has battery, and the values has similar to the has laptop battery. So all these inferences basically mean all the super properties of all the object properties we have asserted over here. Moving next is the Samsung Galaxy S20 S1. So it is a type of smartphone which is manufactured by Samsung. So for the object property that has been asserted by us is has mobile phone battery which is lithium ion, has Adreno graphics card unit which is Adreno 650, has Snapdragon processor of has a instance value of Snapdragon version 855, is manufactured by Samsung and runs on has One UI version 2, which is a type of Android OS. So similarly, we can see the inference object properties and their respective values. So has mobile phone processor is also Snapdragon, has battery is a lithium, has mobile phone OS is One UI version 2, has graphics card is Adreno 650, has OS is One UI version 2, has phone battery is lithium ion B1, has for processor is Adreno 650, again has processor Snapdragon version 855, and has mobile phone graphics card which is Adreno 650. So has processor is one common super object property for all types of processing unit. So this processing unit can be a graphics processing unit and also a central processing unit. And for the data properties, we can say that it has a storage capacity of 128 gigabytes, and has a phone attribute which can be said as a characteristics. It using a dynamic AMOLED capacitive touchscreen. So this touchscreen has a refresh rate of 120 Hz, and the S20 also has a battery capacity of 4000 milliamp hour, and first released on 11/2/2020. It has a display of 6.1 inches, and the starting price which was first released was 3,500 ringgit. Next one is the PlayStation 4, which is of type PlayStation, and this PlayStation is a kind of game console which is manufactured by Sony. So for the object property, we has AMD Radeon graphics which has this value, has PlayStation OS or Orbis OS, is manufactured by Sony, has PlayStation processor Cell BE version 4. And we can also see all the inference knowledge by the processor. So the has game console, which is similar to the has PlayStation OS. So has game console OS has the same values as of has PlayStation OS. The has game console processor is similar to the has PlayStation processor. Has game console graphics card is similar to that of has AMD Radeon graphics. Has OS is also Orbis OS V1. Has processor is Cell BE version 4, and has processor is AMD Radeon CGN. So the data property we have is release date, which was first released on 15/11/2013, and this one has one unique feature bound to only to itself, is that it has Bluetooth connectivity and has price of $299 US dollars, and it has a weight of 2.8 kilograms. Then we have Nokia 3310, which is a kind of feature phone manufactured by Nokia. So this one is having object property, has Yun OS, which is of value Yun OS version 1. So we can see the inference knowledge by the reasoner is showing us has mobile phone OS and has OS, which are of same instance values. So these are basically the super object property of has Yun OS, and this has Yun OS is only bound to a feature phone. And the data property for this feature phone is has release date, which is 1/9/2000, which was the first release date of this Nokia 3310, and has a key attribute which is key based input. That means it has a physical keyboard which is used as an input for that phone, and has a mobile phone display which is only of 2.4 inches, and the starting price was 50 ringgit. Lastly, we have Sony Alpha A7. Sony Alpha A7 is a DSLR camera used for shooting high resolution photography. So this is a type of DSLR and is manufactured by Sony. And we have a data property for this has release date, which is of value 16/10/2013, has DSLR camera feature which is also bound to this particular camera. So it's unique to this camera. So it has the feature as of low light shots, so it can take good photos in low light and shoots at a resolution of 2160, which is 4K, and uses lens which has megapixel of 47.1.
Hi, this is Mohatma Islam. So I'll be writing some Sparkle query for this OWL document, electronic devices. So here we have some classes, object property, data property, and individual. For this purpose, I'm going to run the resolver, then go to the Sparkle query. For the first query, I'm going to find the processing unit which has the maximum clock speed. So I'll write a select statement. Select processing unit clock max clock speed where clause subject is processing unit, data property has clock speed, and object property object max clock speed. I'll writing a nested select query to find the maximum clock speed. So select max clock speed as max clock speed where clause where subject data property has clock speed and the object which is clock speed. I'm going to execute this statement to see the result. So here we can see that we have find the processing unit. This has a maximum clock speed which is 2.8 gigahertz. For the second query, I'll find how many devices have been manufactured by each company. For this query, I'm going to use construct. So construct company property and subject. We'll make a where clause where select distinct company count as devices where y object property is manufactured by subject company. Group by company. Order by descending devices. So this will show me list of all companies that has devices. So here we can see the companies and how many devices has been manufactured by each company. For the third query, I'm going to assign a new value for the release date of an Apple product. So write a select statement, select device as release word plus is object property is manufactured by using bind to assign a new value to the release date. Release. We'll execute this statement, which is find the new release date. So here the device is iPhone X, the company Apple, and the new release date has been binded. For the fourth query, I'm going to show all the devices that's running on their respective operating systems. So I'll use construct and imminent for this query. Construct object property has OS operating system where clause object property has Windows OS operating system. Union will join the second statement. Object property has Android OS operating system. Using union to join the third statement. Device object property has PlayStation OS operating system. So it's showing all the devices that has the operating system. For the fifth query, I'm going to show all the companies that has a starting letter A. So I'll write to select company query clause company RF type object company company TFS label name filter regex name I is used to avoid case sensitive. I'll execute this query. So it will show me all the companies that has a starting letter A.
So now with the overall description of the classes, the object properties, data properties, individuals, and the Sparkle queries, I will now demonstrate an overall view with the reasoner in order to infer knowledge regarding the ontology as a whole. So starting with the classes, this is our hierarchy. If I run the reasoner, lithium ion infers an instance lithium ion battery 1. For the cable class, optical fiber has an instance of this optical fiber type. And these are characteristics, therefore they have no inferences, since they are only used to distinguish between members of a class. In the company, we have defined the following companies, around 24 of them, whereby they are used in order to assert object properties of manufacturers of devices and developers of operating systems. With the electronic device class, it is further split down to consumer device, which groups different types of consumer devices. Now for the camera class, an instance of the action camera class is the GoPro Hero 8. And then for the DSLR, we have the Sony Alpha A7. For the computer class, we have 5 different computer classes. For the laptop, the reasoner infers 2 instances, the Acer Nitro 5 and the HP Envy X360. For the mainframe computer, it infers the IBM Z15. For the personal computer, it infers Lenovo V530 Tower. And for the supercomputer, it infers Titan. And all these infer that there are subclasses of the class computer. Now moving on to the game console, which groups 3 different types of game console devices. The PlayStation infers 2 PlayStation instances, the PlayStation 4 and the PlayStation 5, as well as it indicates it's a subclass of game console. The Wii infers the Nintendo Wii, and for the Xbox class, 2 instances derived from the class are the Xbox 360 and the Xbox One. For the peripheral device, it is a subclass of the consumer device. And the peripheral device is further grouped down to 3 different subclasses: input device, output device, and storage device, whereby they each have their own different types of devices based on the grouping. So for the input device class, we have a keyboard instance, Logitech K200, which is a media keyboard. And for the mouse, we have the Logitech M330 wireless mouse. For output devices, we have the monitor Odyssey G9 developed by Samsung, one of the latest new curved 3D monitors. And for the speaker, we have the Logitech Z200 instance, derived from the reasoner running. Now for the storage devices, again, they're grouped to 3 different categories: the flash memory device, the magnetic storage device, and the optical storage device. For the flash drive, the UFS, memory card, and SD card, there are no instances. However, for the SSD, we have the Samsung 860 EVO SSD instance. Floppy disk has no instance, but hard drive has the HDD version 7, which is a magnetic storage device. And the reasoner shows that for the optical storage device, there is 1 instance for the CD-ROM, which is the disk drive with this following serial number. Now moving on to the phone class, they're grouped to mobile phone and telephone. Mobile phone is further grouped down to 2 subclasses, both being defined: the feature phone and the smartphone. For the feature phone, we have 1 instance, the Nokia 3310. And for the smartphone, it infers the following instances: the Huawei Y9, iPhone X, the Samsung Galaxy S20, and the Xiaomi Note 9. And for the telephone class, we have 4 different types of subclasses, whereby 2 are defined. The desktop rotary has an instance, the rotary retro dial bell desk telephone. And for the wall touch phone, we have the Motorola CT50. And both indicate that there are subclasses of the defined class telephone. Now for the television class, we have 1 3D TV instance that the reasoner derives, which is the Panasonic 32 LED TV. For the HD TV, we have the LG TV OLED. And for the Ultra, we have none. For the electronic device displays, we have 1 LED instance and 1 OLED instance. Moving on to the operating systems, you can see that the operating system class is grouped and has 4 different subclasses, being the computer OS, the game console OS, the mobile OS, and the television OS. In the computer OS, there are 4 more subclasses: the Linux OS, and the reasoner infers the Ubuntu 18.04 operating system, which is developed by Linux. And for the Mac OS, we have no instance. For the Unix, we have the Unix version 7 instance. And for the Windows, we have the Microsoft Windows 10 operating system that the reasoner infers. For the game console operating systems, we have the Orbis OS, which is developed by Sony for its PlayStations. And we have the instance Orbis OS version 1. For the Wii, we have the Wii OS version 1, developed by Nintendo for its Wii game console. And we have the Xbox operating system, which is developed by Microsoft for its Xbox game console. For mobile operating systems, we have the Android, the iOS, and the Yun. For the Android, we have 3 different instances that the reasoner infers: the EMUI, which is for Huawei devices, the MIUI, which is for Xiaomi devices, and the One UI for OnePlus devices. For iOS, we have the version 11 that the reasoner infers. And for the UNOS, which is mainly for the feature phone, the Nokia 3310, we have derived the reasoner derived the instance UNOS version 1. And if a feature phone has this OS, it implies that it is a feature phone. Thus, it can be distinguished from other smartphone devices. For the television OS, we have no instances, but for the web OS, we do have one. And they're all disjointed with one another through the members of the different operating system classes. For the processing unit, we have we have 6 different main subclasses, which is the computer graphics unit, the computer processing unit, the game console graphics unit, the game console processing unit, the mobile graphics unit, and the mobile processing unit. For the instances of the computer graphics unit, we have the GTX 1050, which is manufactured by GeForce. We have the AMD Radeon RX 5700, which is a graphics card developed for the HP Envy laptop. And for the computer processing units, we have 3 different versions of the Intel processor. For AMD Kabini, we have an AMD Kabini instance, which is developed for the Xbox. The AMD Radeon CGN, which is developed for the PlayStation. And the ATI Hollywood R5 500, which is developed for the Nintendo Wii console. For the game console processing unit, we have Broadway SOI, which is for the Nintendo Wii, Cell BE, which is for the PlayStation 4 and 5, hence the 2 different instances that the reasoner infers, and the XCPU, which is developed for the Xbox. Moving on to the mobile graphics unit, we have Adreno 650, Apple GPU 3-core, and 2 different Mali graphics unit. Mobile processing units, we have 5 different subclasses. For the Apple, we have the A11 Bionic chip, which was manufactured and developed by Apple for its iPhone 10 device. Kirin, we have the 710, which is developed for Huawei devices. And then MediaTek, we have one instance, the Helio G85, and the Snapdragon processor developed by Qualcomm. The reasoner infers the Snapdragon version 855. Now moving on to the individuals that we have created. As you can see, this is the following long list of the instances that we have created, and they all serve a significant part to the overall development of the ontology. So starting with the A11 Bionic, we can run the reasoner for all instances in order to infer some knowledge. The A11 Bionic shows that it is a type of Apple A Bionic, since it is a processor built by iPhone for the iPhone X device. This knowledge is inferred correctly because we can see here that the Apple A Bionic is a mobile processing unit. Now for Acer and other companies, which we have around 24 of, these companies are all asserted. It cannot be inferred knowledge, since the companies are used to assert object properties, since companies manufacture electronic devices and they develop operating systems. So if the type is not asserted, like you can see over here, we wouldn't be able to do the proper links. Therefore, all companies are asserted and not inferred knowledge. The Acer Nitro 5 is the reasoner infers it as a type of laptop. And on the right hand side, we can see further object property inferrations from the reasoner. The reason for this is because our object property hierarchy is quite complex and we have many sub-properties. So if we look at the Intel Core processor, it shows the value of the Intel i9 version. However, the same value is produced under a different object property, which is inferred by the reasoner, as has computer processor. And the same thing here with the has processor. Because if we look here on the left hand side on the hierarchy, the Intel Core processor is a subclass of the computer processor, which is a subclass of the has processor. So we can say that this knowledge is inferred correctly. The same thing applies to all object properties with a hierarchy of other properties. The same value will be asserted, however, with the different object property name, depending on the hierarchy. The Adreno 650 is a mobile graphics unit developed by Qualcomm. Therefore, it shows that it is a mobile graphics unit, and the type is Adreno. In the class hierarchy, you can see Adreno over here under the mobile graphics unit. So that knowledge is inferred correctly. AMD is a company, no inferred knowledge over there. The AMD Kabini is a game console graphics unit developed by AMD for the Xbox. So if you can see here, this instance is inferred as a AMD Kabini type, which is under the hierarchy as a game console graphics unit. So that knowledge is also inferred correctly. For the Radeon CGN, it's developed by AMD. However, it's a game console graphics unit developed for the PlayStation, not for the Xbox. Now, if you can see here, the AMD Radeon CGN instance is inferred as an AMD Radeon class, which is also under the game console graphics unit over here. So we can say that that knowledge is also inferred correctly. Now, the AMD Radeon RX 5700 is a computer graphics unit developed by AMD. However, the reasoner infers it's a type of Radeon, not AMD Radeon, since Radeon over here is under the computer graphics unit, as you can see right over here. So it clearly distinguishes between a game console graphics unit and a computer graphics unit, even though it's the same company. Apple is a company, no inferred knowledge over there. However, for its GPU core that it manufactures, it shows that it is a type of Apple GPU. In the class hierarchy, we can see Apple GPU under the mobile graphics unit. Now for the ATI, we can see that it is a type of company, so no inferred knowledge over there. However, for its Hollywood R500 game console graphics unit, it shows that it is a type of ATI Hollywood, which can be seen here under game console graphics unit. Now for the rotary telephone, it shows that it is a type of desktop rotary, which is under telephone class, desktop rotary. So that knowledge is also inferred correctly. For the Broadway SOI, it's a game console graphics unit developed by IBM for the Nintendo game console. So it infers the type as Broadway, which is listed under the game console graphics unit over here. Sorry, processing unit. The CD-ROM shows that the reasoner infers it as a type of CD-ROM. So this instance is a CD-ROM, which is a storage device, optical storage device under here. The CellBE 4 and 5 are both inferred as a CellBE class, since they are game console processing units developed by Sony for the PlayStation. Cray is a company, so is Dell, so there's no inferred knowledge there. However, the EMUI software developed by Huawei is an operating system for its phones, so therefore it shows that it is a type of Android, since Huawei phones are Android based. So if you can see Android here under the operating system, it shows as a mobile OS, and since Huawei develops mobile operating systems, such as the EMUI version 9, this knowledge is inferred correctly. The GoPro is a company, no inferences there. However, for its Hero 8, it shows that it is a type of action camera. The GTX 1050 Ti, a computer graphic unit developed by NVIDIA. So therefore, it infers that it is a type of GeForce, which will show under the computer graphics unit class. So that knowledge is also inferred correctly. This instance of a hard drive is inferred by the reasoner as well, developed by Dell. HP is a company, so it won't show. However, its laptop also infers, the reasoner infers that it is a type of laptop. And similarly, as I discussed with the Acer Nitro 5 over here, these instances that have many inferences for many assertions for the object property will also infer similar knowledge because of the hierarchy and the structure of our object property hierarchy. Huawei is a company, so no inferences there. For the Y9 2019, the reasoner infers that it is a type of smartphone. Similarly, there are more object property assertions here on the right-hand side, due to the same reasons I mentioned earlier. And Huawei Y9 is a smartphone, that is correct. And smartphone is placed under the mobile phone class, which is under the phone class over here. IBM is a company. However, its mainframe computer developed by the same company shows that it is a type of mainframe computer, which is shown over here in the class hierarchy. A type of computer under consumer device under electronic device. Intel is a company, no inferences there. However, it's i5, i7, and i9. The reasoner is also managed to produce and infer correct knowledge by showing that the type as an Intel core. iOS version 11 is also shown as a type of iOS, which is a mobile OS down here. And the iPhone X is a type of smartphone, inferred by the reasoner. And similarly, there are further object property inferences by the reasoner on the right-hand side. Kirin is a Kirin is a type of Kirin, which shows right over here as a mobile processing unit. LED infers LED, and Lenovo is a company, no inferences. With the tower, it infers it as a personal computer, and since we have asserted many object properties, similarly it asserts more and infers more object properties due to the object property hierarchy. LG is a company, and its TV, developed by LG, it's managed to also show that it is an HD TV type, which under the hierarchy is a type of television. The lithium-ion battery of B1 version, the reasoner infers it as a lithium-ion battery over here in the class hierarchy. And Logitech is a company, no inferences there since it's asserted. Now this version of the Logitech keyboard, this version of the Logitech mouse are also inferred correctly. Keyboard and mouse. And this inference shows that since the Lenovo V30 tower is connected to the wireless mouse, it also infers that here it connects to that personal computer, since this property is symmetric. Logitech Z200 is a speaker, inferred correctly, and similarly here it infers that it is connected to the V530 tower, since in that tower we have asserted as such with the keyboard, with the mouse, and with the speaker as well. So these two game graphics unit are a type of Mali, which we can see in the hierarchy is listed down here as a mobile graphics unit. So since this is a long list, I will just show the type of the type that the reasoner infers. So for the MediaTek, it infers the MediaTek. Microsoft is a company. The Windows 10 infers as a Windows operating system over here. Windows operating system is under the computer OS. And the Xiaomi the MIUI, sorry, which is for the Xiaomi devices, it shows as a type of Android since Xiaomi phones are running Android-based software. Motorola is a company. The wall touch phone is inferred by the reasoner for this instance. Optical fiber for this wire. Company. The Wii game console is inferred here through the instance. And the Nokia 3310, the reasoner manages to also assert it as a infer it as a feature phone, since it is asserted here that it is has YunOS version 1. So since this property had a restriction that only feature phones can contain this YunOS, therefore it manages to distinguish it as a feature phone. Similarly, it infers more object properties here since the YunOS is a subclass of mobile phone OS which has a OS. NVIDIA is a company. Odyssey is a monitor, inferred by the reasoner, which is also correct, developed by Samsung. The OLED display shows that it is a type of OLED, which can be seen here for the electronic device display. So One UI shows as a type of Android, developed by Samsung. Orbis OS shows as Orbis OS. This version 1 instance shows as Orbis OS, which is an operating system developed by Sony for the PlayStation. So if we see Orbis OS here in the class hierarchy, it will show as a game console OS over here, and so on. These are the following inferences by the reasoner. One thing that we can notice here is that these two Xbox versions are completely different instances. However, the reasoner manages to infer that it is a type of Xbox. Same thing with the PlayStation over here. And then finally, the XCPU shows that it is a type of XCPU, which is a console processing unit. Right here. And to conclude with Xiaomi Note 9, it is a type of smartphone. And finally, for the last instance, the YunOS version 1, it shows as a type YunOS since it's a mobile operating system. So YunOS will be under the mobile OS hierarchy, right over here. So with that, we can see that the reasoner managed to infer plenty of knowledge due to the many object and data property assertions that we have made. So therefore, the reasoner was managed to assert that every instance is correctly identified to the correct class. So with that, it concludes our ontology video demonstration for the group assignment number 5, whereby we clearly described our detailed 7 classes, 5 object properties, 5 data properties, 5 Sparkle queries, and with the overall running of our ontology through the reasoner to infer some knowledge. Thank you.